a material scientist, engineer, and inventor. And we know she's an inventor because she was actually on a TV show called The New Inventors, going back, I don't know, what, probably 2 decades now, decade and a half now. Um, and she is revolutionizing recycling science in Australia and around the world. She's renowned for pioneering the high temperature transformation of waste in the production of a new generation of green materials. She is the founding director of the University of New South Wales Sustainable Materials Research and Technology, or SMART Centre. Worked really hard on that acronym. I always like it when that happens. Would you please make very, very welcome Professor Veena Sahajwalla. Veena, please, welcome to the program.
Thank you, Chris. Thanks so much for having me, and really thank you for that very warm welcome. I just wanted to be able to say what a delight it is to be here, and to be able to share a little bit of our journey at the Smart Center, and hopefully to give you a bit of a sense of the fact that when we talk about sustainability, and what we are really trying to achieve is such a big holistic outcome, where we know very well that the journey is exciting, and I hope that from a little bit of this story that you hear from what we've done at the Smart Center, that this will also be something that you'll be excited when you think about, how do we actually get to a sustainable future. So I'm going to talk a little bit about, of course, the science, the technology, and I'm going to tell you a little bit about our microfactories. We've actually been running these microfactories, which is based on the scientific work that we've done at the University of New South Wales in Sydney. And we're also really privileged that when we talk about recycling of waste, and particularly when we talk about materials that are complex waste, like plastic waste in our electronic devices, there are so many things around us that, of course, when you look at it, sometimes it can feel a bit overwhelming. But very much what today will be all about is to share with you the fact that when you start from the very fundamentals of what science can teach us and what it can inform us and hopefully inspire us, that's really where the transformation happens, is when we start to understand that science, but then also related to that, we can start to see what kind of technologies are possible to recycle our waste and convert them into value-added products. And we're also privileged here to be hosting Sustainable Communities and Waste Hub. This is funded through the federal government here in Australia, and in my role as the hub leader for Sustainable Communities and Waste, I actually have the privilege to be bringing together incredibly inspiring scientists and people who work in the area of government and industry and research to all collaborate and work together. And I think when we can all work together and come together, we can actually start to see that collaboration delivers impact really in a way that we would have never imagined. And also it's a lot of fun. So hopefully you'll get to see a little bit of who we are at the Smart Center. We're looking at research that ultimately is all about delivery of environmental, social, and economic benefits. So developing our different kinds of our materials that we need in our everyday lives is, of course, the motivation, because we know very well that when we look at all kinds of products, whether they are in our built environment, whether they are as part of those electronic devices that we use, or those really simple plastics and metals that you can recognize, and often we wonder what happens to these materials when the products are no longer being used. So when we start to talk about that holistic solution of recycling, we have to understand that fundamentally those materials in there could in fact undergo the transformation. And if we can actually show that there is a pathway to manufacturing and remanufacturing a lot of these end-of-life products in one form, and that they can be converted into a whole new form. They can be put towards remanufacturing. Then we can develop new solutions for materials processing, which is what we're doing, and also new solutions for materials production technologies, which is where, of course, some of our solutions come in, like, for example, our micro factories. And I'll tell you a little bit more about that a bit later as to why micro factories. But just as a little bit of a piece that I'm sure you may be able to relate to is this presence around you when you start to look at waste resources. In this particular case, when you start to look at electronic waste, and you start to actually hone in and look at, in this particular instance, pile of circuit boards, you very quickly realize, of course, when you think about it, that these kinds of electronic systems, they contain very important metals like copper and tin. But of course, why is it that we still put them away as a pile of waste? And in many cases, of course, people will put them towards more traditional smelting technologies and of course try to recover those metals. But what happens if you are actually in a location where you might not have access to these kinds of traditional technologies? So what we are doing, of course, is showing that even on a micro scale, we can take important end-of-life products, like in this case, our circuit boards that are there in every kind of electronic device, and show that we can thermally transform them into these important metal alloys like copper-based or tin-based alloys. And what this piece of research that we have published has shown, that indeed by controlling that temperature at which the transformation can take place, we're actually producing these different kinds of metal alloys. Why does that matter? Because of course, we don't have to rely upon always one big, large smelting solution, because keep in mind that when you talk about a large mega operation, they are typically set at certain specific operating conditions. So you might have a certain set temperature at which you might be able to make copper in a copper smelter. But in our case, what we are really looking at is selectively converting each of these different kinds of outputs at the right temperature. So for example, if we know that we can make tin-based alloys at relatively lower temperatures, in this case, we've shown that, we don't have to heat everything up to temperatures at which copper is made. So the ability to be very selective and carefully control how waste undergoes that transformation really allows us to be very careful in the way we use, of course, our waste resources as a feedstock, as a raw material for manufacturing and remanufacturing. And of course, why does that matter? It matters because, of course, the world needs a lot of tin and copper, and as I'll show you, many other important metals to be able to deliver to energy and electrification and all of those solutions that we need in our everyday lives. We do need important metals. So the reason why we're looking at our microfactories as pathways to achieving these kinds of outputs is that in many parts of the world, including, of course, in Australia, we've got large distances to cover. You can't imagine that you're going to be taking all of that waste, collecting it and aggregating it in one location, and then doing the transformation. So what we are really talking about is that when we start to think about these microfactory solutions in the future, we will be able to, as much as possible in a local and a regional setting, we'll be able to transform these into different kinds of important materials. And so that's when it comes to metals. But what about when it comes to all those important batteries? Because quite often when batteries are collected at the end of their lives and you don't know what to do about it, you often wonder what you do about those batteries. You've got now situations where you can go back and look at what's actually present inside batteries. And indeed, what we have shown is there are important metals that are present inside these kinds of in this particular case, you're looking at a zinc carbon battery. And of course, all of that material that's present inside the batteries, these are the kinds of materials, of course, we want to be able to recycle and reform and remanufacture them, because they're far too important to be seen as waste. And so, of course, when you start to harvest those metals, you can actually find multiple solutions. And we've actually indeed shown that whether it comes to all of these elements that you're seeing there, zinc, manganese, we know that we can actually process them, but they're not as straightforward, because the powdered black material inside the battery that you're seeing there, that powdered material, of course, contains different types of important compounds that are mixed together. So traditional recycling, in a way, that is the like for like conversion, sometimes it's not possible. We have to find ways in which it doesn't always have to end up in a smelter. And if we do that in a smaller, localized, regional setting, we're actually innovating and developing not only new material solutions, but we are also developing innovative ways in which we can manufacture. And that's exactly what we've done here when it comes to different kinds of plastic. When you think again about all of those plastic casings that are there in your electronic systems, whether they are casings on your laptop covers, your printers, those important plastics outer casing in your remote controls, lots of important high quality plastics. But of course, how do you then convert those plastics so they don't end up in landfill, or they don't just simply get thrown away, thinking that really we have to burn our plastics. We should not be looking at burning any of our materials. We should actually be looking at remanufacturing, and then this way our solid materials, like in this case we're talking about plastics, are converted into more plastics so that it can be remanufactured over and over again. And so in doing so, we don't have to go back to the original material. We don't have to go back to the original polymer. We can actually put that polymer back into remanufacture. And so in this case, what we are doing is we're converting our waste plastics in our micro factories into plastic filaments. Those plastic filaments, and these are 100% recycled, they then get converted into different products by using, of course, 3D printing technologies. So the idea that we can actually convert them in this manner, that waste can get converted into high value products, opens up pathways for our micro factories. And that's exactly what we're doing. But the other reason why it does matter, more than just thinking about, of course, recycling and remanufacture, is that we are also thinking about how this can convert that waste resource into ultimately social and economic opportunities. So that then means that we can start to imagine that holistic solution, that holistic picture of how these kinds of waste resources can also create local jobs. So this is exactly why micro factories in our regional setting, where waste might be collected through those local transformations, can indeed be put towards remanufacture. And that's exactly what you're seeing happening there, that green manufacturing of plastics. You can see the plastic filaments being fed into 3D printers. And of course, you can print and manufacture, and you can imagine that a local manufacturer and local operator can indeed produce these kinds of different kinds of products that society needs. And from our perspective, of course, the ability to actually show the different kinds of plastics, because keep in mind that there are many, many different kinds of plastics. And of course, some of them that people might say, oh, well, but this is impossible to recycle. Well, the reason why people are saying that is that because in many instances, a simple conversion of like to like a water bottle into more water bottles, is possible for some kind of plastics, like your PET water bottles, because those can be produced from 100% recycled bottles and can be converted into new production. But in a case like this, where we're looking at the more complex polymers, we can show that it doesn't have to always be converted like to like, and you can make different kinds of products, because these kinds of materials in all instances are important. And of course, if we can just have a look as to how much production has taken place already on our planet. And here's an example of our e-waste microfactory that we launched many years ago. From those micro furnaces at the back of the room, from that robotic arm that is sitting at the front, you can see in there, the conveyor belts where there are circuit boards. We've got basically all kinds of waste devices that can then come into a microfactory. And there's so many different kinds of input feedstock materials that have already been manufactured on our planet. So imagine a future where we're looking at all kinds of production and transformations, whether it is us producing our metals and metal alloys, or plastic filaments, or indeed batteries that can then give us more of those important materials that can go back over and over again into remanufacture. And if we can start to imagine a future where we are interconnecting the recycling and the reforming, remanufacturing with local production, and creating those supply chains where when a waste comes into a local waste collection facility, it's not seen as a burden to our environment, but rather it's seen as an opportunity. And I think once we start to see these incredibly new opportunities, we actually have so many different pathways in which we can convert them into value-added products. And here's another example of what we have actually done. Our green ceramics microfactory, which is producing all kinds of products for our built environment, for building products application. For instance, our green ceramics that we put into production in this particular example here, you can see that we put them into floor tiles, into those island bench faces, into those kitchen splashbacks. All of this is basically made in our microfactories, and they're made from waste glass and waste textiles. So again, now you can imagine that the ability to engineer those kinds of products that are made from our waste resources, but to do it in a way that is value added, and of course, to do it in a way that these are high performing, highly engineered products, means that we need to have the ability to not only control our input feedstock, we also need to have the ability to also know how we manufacture our products. And this is one of the things that we have produced in our microfactories. Because of course, if somebody tells you, well, does it have the right properties? Does it have the right qualities? Absolutely. These are the kinds of things we need to measure. But the ability to measure properties and how we do it also is very closely related to the underpinning foundational science. And that foundational science, or what we are calling as micro recycling science, is what we have developed at the Smart Center. And taking that science and then using that to be able to put that into practical production opportunities is where the excitement lies for us. So our industry partners are producing these products and indeed finding different ways in which we can be also extremely creative. So one of our researchers also produced these beautiful green ceramic pendant lamps that you can see. And to be able to make these beautiful shapes, so it gives us the opportunity to create all kinds of products, is really what our microfactories are all about. The ability to take waste and convert them into green materials and products, which are then designed and customized for different kinds of applications, is what's possible in our microfactories. So how does all of this come together? And if you're sort of wondering, okay, well, there are so many different things, of course, that we need to think about how science and technology and engineering can all play a part. And of course, also understanding, as we said, manufacturing and the properties of materials and products. How does it all come together? Well, if you look at what circular economy is all about and circular solutions is all about, which is what we like to think that we are actually showing to the rest of the world, that it is important to recognize that as owners of waste, whether it's in our homes or in our places of work, we know that local governments and local businesses can collect those waste. We know, therefore, if the waste is already being collected, then how does that actually go back into production and remanufacture? And this is where producers and designers come in. So we're connected back into those small to medium enterprises, those not-for-profit, those communities, those businesses that know how to manufacture, that are excited about taking waste resources as part of production. And this is what we've done with our microfactories. And once those products are made, then we are actually also then feeding that back into the hands of end users. And again, end users, well, who are the end users? Well, it's kind of all of us. If you think about the fact that whether it's in our retail sector, in our construction, in transport and government, in industry, we're all part of what we're saying are the end markets, the end users. So if you think about circularity in a way that the transformation and design and manufacture of products will always change and it'll be redesigned, then of course what we are really saying is that every item that reaches the end of life or it becomes obsolete or doesn't work anymore, every product should actually be seen with a view to actually taking it to the next destination where it's not going to be landfill or it's not going to be undervalued or indeed downcycled, but rather to be able to see that as a whole new bigger ecosystem. And that's really what an ecosystem of materials, of products should look like. That continuous journey of materials transformation is important. And this is back to that point that we were saying earlier, that we need to innovate, we need to collaborate, but we need to start to think about, the bigger holistic picture. Why are we doing this? We're doing this because we know that we will be able to deliver better and better outcomes and improve people's lives. We'll be able to improve outcomes for businesses, for manufacturers. We can actually really start to imagine how we can go from generating ideas to delivering impact. And if we have to deliver impact, we have to create those new opportunities. We have to see everything, no matter where we're located in the world, whether it is in a small remote community or whether it is in a large township, we can actually start to show that it is possible to be able to imagine that remanufacture and creating materials from waste is something that we can show is possible. And this is where our microfactories come in. Again, all kinds of complex waste resources. If you can imagine things like I was telling you earlier about our green ceramics microfactory, which is taking in materials like waste glass and waste textiles. And in all of these examples, we know waste glass is just generated as part of everyday life, whether it comes as you see in this case from our cars, all those automotive windscreen window glass, for example. And of course from our built environment, so many different things from our homes. We know that some of the glass is considered recyclable when it is pretty much a traditional glass going to a traditional operation. But when it comes to the more complex, these glass surfaces that we're used to seeing, of course, in our cars, they are complex. They are designed to keep us safe in case of an accident. So very different kind of structure. These kinds of laminated structures don't make it necessarily easy for recycling in a traditional setting. So what we are really saying is that why don't we look at how complex glass and of course, when it comes to things like waste textiles, again, we have similar sort of challenges that we know a lot of our textiles is made out of synthetic materials like plastics. And of course, we also recognize fully well that it ends up in many instances in landfills and incinerators. So why don't we see that as another important part of feedstock and raw material? But for things like glass and textile to become part of raw materials, we do need to have an eye on what kind of products we could be making, and not necessarily every bit of fiber from textiles has to be converted into new fiber. Yes, in some instances, when it is possible and feasible, absolutely, we should be converting and recycling and reforming that into more and more of those kinds of products. But of course, what happens is that we've got now the planet getting really overwhelmed with waste textiles. We know that there's ample of materials that have already been produced. So how do we, of course, reduce our consumption? How do we reduce these kinds of materials going to landfill? Is by actually looking at the UN SDGs and examples like UN SDGs of number 12 that talk about responsible production and consumption really shows that we can, start to reflect upon how we can take these materials and put that back into manufacture. So these are the kinds of examples of the products that we've done with our industry partner, our industry partner called Kandui Technologies. Right here in Australia, I've been manufacturing all kinds of green ceramic products. So the kinds of things I was telling you earlier, you can look closely at those beautiful floor tiles, for instance, with different colors, and of course, walling applications and furniture applications. In all of these cases, it is possible to make these really hard and durable, highly functioning surfaces from our waste glass and textiles. And of course, our manufacturing capability has made it possible for our industry partners to really be very creative. And we are, of course, locating these kinds of micro factories in different regional communities in Australia. So creating those local supply chain, regional opportunities and jobs and manufacturing, and really doing it in a completely different way to where in the past, we had probably been told that everything has to be done at a large scale. Everything has to be, all about economies of scale. Whereas what we are doing is shifting the mindset completely here and showing that it is possible to be able to think about economies of purpose. And when we talk about economies of purpose, this is exactly what we're talking about, is that what is the purpose here? Why are we doing this remanufacture? We're doing this because we want to be able to divert our waste away from landfill. We don't want to see anything as a waste. We want to see every product being diverted away from landfill into remanufacture. And if we can say that that is our bigger picture purpose, and if we can show that we are doing this because we care for our planet and we care for our people, this is important. We don't want to have these piles and piles of pollutants that are sitting around in different parts of the world, polluting our environment. And in many instances, of course, really causing harm to the quality of the air that we breathe, because of course in so many areas in the world where people don't have that ability to manufacture and remanufacture, then a lot of these materials could possibly end up in landfill and causing contamination. So what we are really talking about here is that starting to think about those economies of purpose, those micro manufacturing potential opportunities closer to where the waste is being collected, allowing those waste resources to be put into production is important. And this is where, of course, this journey has taken place for us. These are examples of our micro factories. You can see in the top part of the picture there, our micro factory at the Smart Center at UNSW. And at the bottom of the picture, there's the micro factory that we've set up in a regional town here in Cootamundra. And you can see, of course, various small scale systems that we've put into play that allows us to, of course, bring in and create these innovative supply chains from waste resources so that we can indeed manufacture these different kinds of products. So when we think about that holistic solution for manufacturing, yes, recycling is a part of it, but it's only the beginning of that journey. When you think about going beyond recycling and talking about reforming and remanufacturing, then we are indeed showing that we can decarbonize and reduce our carbon footprint by taking already existing materials. We don't have to go back to virgin resources again. We can take already existing materials, put them back into production. So the energy that went into making those materials, those metals, those polymers, glass in the first place, when we actually want to put those back into production, what we have done is we've actually shown that we can reduce our carbon footprint because we don't have to make those materials again and again. Those initial materials that were made in the first place, if they can be recycled and reformed, then we're saving on energy as well. So it's not just about the fact that we are recycling, but we are also saving on that energy that went into manufacturing that material in the first place. And so a lot of metals that are, of course, energy intensive to produce, each time you recycle it, you're actually saving on energy. So we are on that journey of thinking about how we're going to get to decarbonization when it comes to manufacturing and remanufacturing is absolutely by going and having a look at, do we have those supply chain systems? Do they work for us? And if not, we need to develop them, and we need to start to think about how manufacturing, in this case, I've given you an example of a green ceramic product that, of course, can be made from waste glass and textiles. And of course, from our perspective, the implementation journey that we have embarked upon this year, some of these tiles have actually been installed as wall applications in Sydney Olympic pools in both men and women's change rooms. And we can see that these beautiful tiles that have been deployed are actually something that were made out of a micro factory. So it's giving us a lot of hope for the future. And for us, making all kinds of products means that suddenly we will start to see, which is where we are at this point in time in our journey, is the escalation of interest in recycling, remanufacturing, and also our microfactories. The example of microfactory that I gave you earlier, set up in Cootamundra, takes indeed waste mattresses. And of course, as you know, waste mattresses contain a lot of waste textiles, takes a lot of locally available glass. And from our perspective, this microfactory that we launched early last year is an example of how you can get into a region, a remote and a regional community anywhere in the world and actually go in there and set up these kinds of systems. So what does it all mean ultimately for circular economy? This is really what we are saying is circular economy in action, where the solutions show that we can connect recycling and manufacturing and indeed show that different pathways need to be developed. Those different pathways are important because you can actually perform those value-added activities in our communities, and we can divert those wastes away from landfill. So creating those local jobs, local solutions is important. And this is what I was showing you earlier. You can see that very much waste plastics on the left-hand side of your screen there, all kinds of plastic products coming in and indeed being channeled into our filaments microfactory. Those filaments then being used for 3D printing. So the kinds of things we have in 3D printing, you can see these examples there, these clamps, for example, that were manufactured in a microfactory. And these clamps are, of course, you might sort of say, well, they're simple items. Absolutely they are. But the fact that we've shown that they can be manufactured in microfactories from those plastic filaments that then can be converted into these manufactured and highly engineered products and being used by industry right here in Australia is an important outcome for this journey, because the more and more of these kinds of examples we show that it is possible to be able to not only manufacture, but to also have industries that are coming along on that journey and wanting to use those kinds of products as part of manufacture, goes to show that we can actually have that holistic thinking around our supply chains. We don't have to go back always and say, well, I always purchase this from that same supplier, so I will always do things in a certain way. We can actually challenge the norm. And by challenging the norm here, we're asking those important questions. How many of these products are being made from recycled content? How many of these products are being made in our local regions? Are they the products that are actually doing the right thing when it comes to environmental implications, when it comes to social outcomes? You know, we can actually think about the opportunity that our resources offer us, an opportunity to deliver on social, environmental, and economic outcomes. So we have to question those conventional supply chains. And really, we have to say, well, in a conventional setting, we would have had products that were made and they were used and they were just simply disposed of. And we would not have given it second thought. But when it comes to what we're talking about, these kinds of circular solutions, we know that it is much, much more complex and much more sophisticated. We can't simply see those as disposable items anymore. We need to start to see all of our products as part of this holistic solution where we might be able to reuse them. We might be able to, first of all, reduce how much we consume. And if indeed products are repairable, then we should be repairing them, getting that out into the world of repair and getting them out into the world of reuse. And ultimately, when it goes past that point of use and it's no longer repairable, then it can be recovered and recycled and reformed. And so all of those materials can be redesigned and remade into new products. So when we start to think about that holistic solution in a way, we know that societies and economies are locally supporting each other and local integration. So what we are really talking about here is that that piece of collaboration, again, becomes even more important, because we know that the journey that lies ahead of us is going to be something that we need to all come together and inspire each other with our stories of how we're doing things better. So what does this mean in the context of our strategy for collaboration at the Smart Center at UNSW in Sydney is that we are working with our communities, with our governments, with our businesses, our industry partners here in a local and regional setting. Yes, many of them are multinationals, but they also are committed to showcasing that we can, in our setting here, we can establish localized recycling and remanufacturing solutions. So these, of course, coming together of this collaboration with researchers means that we really have to take the time to ensure that we understand each other's cultures and the way we define success. Because of course, what would success look like? You need to start to also ask yourself that at a personal level, at a community level, at a level where professionally you start to look at how do I want to define and shape the future? How do I want to boost sustainability? What role can I play? Can I inspire my local governments? Can I inspire my local businesses? Can I actually start to see what kind of career opportunities are there for me, whether it is in research, in industry, in our communities? It doesn't matter. It's much more about thinking about that integration of what does this mean at the larger level? How can I deliver on impact and all those great ideas that I might want to work on? I know that those great ideas that I might have that can actually deliver on so many benefits to our societies. And of course, ultimately, this is what we are doing in terms of our own collaboration at the Smart Center, is working towards that global solution of microfactories, that we know that we can produce these materials, these green materials from waste. And of course, being able to do that in a decentralized way, setting them up in different parts of Australia is the goal. We're already on that journey already. We know that this is going to help us with generation of jobs and economic benefits in our communities. And so for us, we very much think about the transformation. Our vision has always been about transforming waste into value. And if we are going to see that transformation, we have to have that holistic picture of connecting the products that we will need in the future. We already know that the kinds of energy storage devices that we need, the kinds of solutions that we need for medical applications, for industrial applications, we know those complex materials are going to be needed. Those complex products are going to be needed. So on one hand, we've got all these materials that we are now, of course, seeing it as not just waste, but seeing it as an opportunity. So what kind of multiple pathways do we need? And this is where, of course, that recycling science and the knowledge and the kinds of technological pathways that we are developing is important, so that we don't just see the easy way of sending things to landfill, but rather we stop and challenge, why are we sending things to landfill? Why can't we imagine solutions that are going to keep things away from landfill? And this is where, of course, we've introduced that fourth R. You've heard me talk about recycling and reforming and remanufacturing, but we have to go beyond the 3 R's of reduce, reuse, recycle, because we know that, these kinds of complex products really cannot just be solved, and their challenges can't just be taken place by the more conventional form of recycling, of converting like to like. So we have to look to that fourth R of reforming. And so if we start to look to that fourth R of reforming, we have to go right down at that level, that micro level detail, to start to see what are some of the materials that are embedded in all kinds of waste. And at that micro level, we will then be able to innovate a whole new way to reimagine. So remember, I was talking about those batteries that contain zinc. We are showing, for example, that we can create those important products. And in this particular case with zinc, we've shown that we've produced zinc oxide. So ZNO, zinc oxide, is an example of a product that we've created, is an important output that can go back again into important applications. So the fact that we might have taken a waste battery, seen those important elements in there, like our zinc and manganese, and talk about transformation of zinc into this conversion to zinc oxide, manganese oxide, and of course, same thing could apply into our lithium-ion batteries, and of course, then the list goes on, our solar panel waste, and so on and so forth. So the transformation where indeed our end-of-life materials are seen as valuable raw materials for remanufacturing, so that we are no longer just seeing it as a waste, but indeed as valuable feedstock. So this is what we have done when it comes to green steel. And just before I start to wrap up my talk, the last bit I wanted to give you was this example of, have we really achieved that success? Have we brought along industries on this journey of that reform that I've been talking about? And this is exactly what I wanted to be able to show you, that our ability to indeed look at this transformation journey that you can see in the middle of the screen there, where we have taken waste tires, and we have indeed shown that polymer injection technology. So by injecting these kinds of waste tires into our furnaces, which make steel, we have reduced our dependency on traditional coal and coke. Traditional coal and coke delivers on carbon that we need to make steel. Steel is an alloy of iron and carbon. But in our instance, the reason why you're seeing that bubbling phenomenon at temperatures at which steel is being produced is that we're actually showing that we can liberate hydrogen molecules indeed from our waste tires in situ, inside that manufacturing operation. And the ability to access hydrogen molecules from tires is possible only under certain conditions, and in our polymer injection conditions, where that hydrogen that then gets liberated gets utilized to convert iron oxide into iron. So the ability to recover metals from basically our manufacturing operations, where we can then reduce our dependency on coal and coke, and to be able to have that kind of reaction that you're seeing there in the middle of furnace. These are the micro transformations that are taking place, where the molecules that are present inside rubber are not seen as a rubber tire, but those molecules that are present inside rubber are seen as important molecules that can liberate, in this case, those hydrogen under indeed our steel making conditions. So for us, of course, this is important because the world has got lots and lots of waste tires. But if we can show that with our technology of green steel polymer injection, we can indeed produce green steel, and ultimately our goal is to get to that point where in this kind of process that we can get rid of coal and coke altogether. At the moment, we're not yet there. We're basically on that journey where we've shown successful commercial production of green steel by using our waste tires as a partial substitute. And as we continue on that journey, we will be, of course, getting to that point where we will be fully able to replace our coal and coke. And therefore, in EAF steelmaking, we'll be able to bring about that transformation. And we have to do that. We have to do that because, of course, the world has got significant quantities of waste tires. And this is where, of course, on the other hand, the demand for green steel is increasing. So I wanted to just kind of wrap up at the end and leave behind that big question of why we need to innovate. We know innovation is important. It's important because it delivers important outcomes, not just in Australia, but of course, globally. It allows us to, of course, start to imagine the benefits for our communities, for our businesses. And indeed, we are always recognizing some of those challenges that lie ahead for us, the challenges that we know we have to look after our environment. We know we have to look after the kinds of material resources that we need. So therefore, we have to generate always those exciting new ideas and indeed convert them into new solutions so that we can deliver impact. And of course, the journey starts for us with all of you. And this is an example of what we do at the Smart Center, where we all come together. You can see in our microfactories, our communities that come along, have a look at get excited about what science has to offer. And I wanted to leave you with this thought, because I'm sure you've been to many labs and universities, and you'll see a lot of labs and videos through this virtual setting. And of course, the ability to see and to be inspired is really what we hope that by sharing our stories, we share the story of inspiration, and you do the same, and indeed deliver a better outcome, a win-win outcome for our people and for our planet. Thank you very much, Chris, for having me here today. And certainly thank you for the opportunity to share a bit of our journey on on the Smart Center. And I'm certainly very privileged to have had the opportunity to speak to your class this evening.
Thanks so much, Veena. Look, you wouldn't believe the number of questions that have come through on the chat. I don't know if you've been watching. So listen, the first thing I'm going to say to everyone is Veena actually told me before we started she's got to go in not a huge amount of time. She's got a really important meeting that she's got to get to. So let's get through a couple of questions then. I thought we'd start with, there's one which kind of sums up a bunch of different questions. Emma O'Brien, are you out there? Do you want to ask your question? Throw your microphone on and ask your question about the cost of these things.
Yeah, so are recycled materials that you're creating, are they more expensive for companies than it would be to source completely new materials? And how would you overcome this economic challenge?
Yeah, no, good question, Emma. And as you can imagine, with any new technology, I mean, this is like literally in the lifespan of making these products, it's like a tiny little baby that has literally just been born out of the labs, and now it's taking its first steps out into the real world. For us, really, the most important thing has been to be able to prove the science and, of course, the quality of materials that we make. So we want to be able to produce high quality products, and indeed the kinds of products I showed you examples of, those green ceramics that we've deployed. They are at the point where we're starting to see how they can become cost competitive. So yes, it is competing at the price level where it's not about making the cheapest possible product, but rather to see at the premium end of the spectrum. As you can imagine, if you were making let's use that example of those green ceramic tiles, that ultimately you can have a target of making something that is cheap and low quality, or you can take the target of really having something that's premium and high quality. And we've really chosen to go at the premium end because we want to be able to make products that are sustainable. And this is the point around sustainability, is to have it so that it's high quality and it reduces that carbon footprint of products that ordinarily would have sourced virgin, feedstock like virgin stone and other materials. So absolutely, in a broader sense, our micro factories that we're developing are designed to be able to produce cost competitive products.
Yeah, that's kind of part of the point, really, isn't it, Veena? That if you produce something which is 10 times the price, no one's going to buy it. Why? What's the point? So you've got to be able to get in there at an affordable price point, and that's part of the challenge.
Well, exactly, and that's why I guess, Chris, the reason why we wanted to have our own pilot facilities at UNSW, which is what we've been doing, and indeed our micro factories, is to be able to show that we can increase our productivity and production capacity. It may be a micro factory, but that doesn't mean that we can't keep enhancing productivity. So what gains we're seeing out of a micro factory and in terms of the production capacity is what ultimately will help us show that we can compete very well with existing opportunities.
So it's kind of the opposite of a microbrewery, which makes really expensive, small amounts of really tasty beer, whereas you're making really good stuff, but selling it at a really good price too. And there's another question which sums up a whole bunch of them. So I'm going to throw to Autumn Rhodes from the USA. Do you want to throw your microphone on and ask your question about sort of globalization, really? Going global with this stuff. You out there, Autumn?
Yes, hi. So do you think it is possible for everyone for this idea to be integrated country and worldwide? And what are some of the limitations or reasons why countries and companies wouldn't accept this method?
I sincerely hope, Autumn, you're not actually driving while you're asking this question. I'm assuming you're in the passenger seat at this point. What would be some of... In the backseat. What, Veena, what would be some of the limitations? What would be some of the reasons why this might be difficult for areas or countries to be able to integrate? Or is it truly global?
Oh, look, I mean, this is why, when I put up that slide of microfactories being global solutions, is because one thing we all have in common, no matter where we live in the world, is we all generate waste. We all have access to waste resources. There's no shortage. You'll be surprised when we started our microfactories and we started talking about waste textiles and things like that. Everybody came out of the woodwork saying, can we give you some of our supplies, right? So I guess, Autumn, I can sort of certainly assure you that there's no shortage, as I'm sure I don't need to tell you, in terms of waste resources. And for us, what we have really started to have this conversation, certainly in Australia, is these supply chains where we need to stop and challenge the traditional notion that this is always how it's done. Oh, but we've always done it this way. We've always sent this material off to that site, or we've always done it that way. And I guess the challenge will come when we start to say, look, if we set up a microfactory in some parts of the world, it's nothing other than having a controlled supply chain of feedstock. Yes, it's a waste resource, but you still have to see it as a highly value-added material that can only be value-added when you make something from it. We've been talking about, economies of purpose, but that doesn't mean that you can just kind of throw everything and everything in there. So having that controlled supply chain, having people in the world of business and collecting waste, being part of that ecosystem of supply chain, and being committed to manufacturing products from waste. And the other side, of course, are consumers, people like all of us. What we are seeing is that the uptake in Australia has been absolutely very humbling for us, where people are really excited about accessing these products and really wanting to be, out there at the front of line to be able to say, oh, but in our manufacture or in our buildings, we want to put those in. Where can we access it? So we've been very humbled with the demand for our green ceramics, for instance. So I think it comes down to both sides, which is on one side, it's about supply chains and supplies of materials. And on the other side, it's about all of us as consumers. From the offices in CBD. I mean, we've had so many meetings with people who've got offices and smaller operators and consumers. Everybody has always come back to us with a very positive feedback about how incredibly amazing those tiles look and how they would love to have that in their own refurb, in their retrofit that they're doing. Doesn't matter how big or small the retrofit might be. And that's the important thing. We know buildings and many spaces undergo refurbishment very often in their lives. So are we all going to take that responsibility to say, next time there's an opportunity to do refurb and retrofit, I'm going to choose my products with a different set of values and priorities. And that's what it really comes down to. What are my values? And if I'm working in a place or if I'm using products, next time, what kind of products am I going to source? So I think, to me, it is something that really comes right back to our values. Do we care for our environment? Do we care for creating these opportunities? And I think, to me, this is what we're seeing in Australia, the positivity and the really positive sentiments, whether it's a large corporate or small businesses or local communities. I think, to me, we're seeing that across the spectrum, where people are excited about what we're doing and really getting excited about getting their hands on some of our products. So we're overwhelmed with the demand for the kinds of green ceramic products that people want from us, which I guess says a lot. Says a lot that there is a lot of hope that we have for the fact that people, when they make those choices, they bring both their head and their hearts together.
I think what you said a second ago, Veena, basically answers probably 75% of the questions in the chat, which is, but how do you convince companies to do this? How do you ultimately what you're talking about is changing the way that we think about this, both as producers, but particularly, most importantly, as consumers. Listen, Veena, I think we've got time for one more question before you said you needed to go, so I'm conscious of that. And particularly fairly early on, there was a series of questions which are all kind of summed up by a question from Vicky Shuang, if you're out there, basically asking, how can we help? What can we do? And the students particularly. So Vicky, are you there? Have you got, do you want to ask that question?
Hi, I'm here. I just wanted to know, how do you suggest like end users or like students can help to like increase or like support the processes of transforming waste to high level resources? Like other than donation, is there another way we can help?
Oh,
And
look, absolutely.
it ties into one of the other questions, which was what degree should we use to get into this as well? So Veena, over to you.
Yeah, and Vicky, that's a really, really good question, right? Because I think to me, you know, all the questions that we've seen coming from your colleagues around supply chains, around production, around opportunity and cost, and what can we all do as individuals? I think they're all amazing questions because I think to me, what's really nice to see is how people are getting super excited about these kinds of opportunities. And I think the best way you can indeed help is start small in your local community. You know, you might have your local government or local community that is, you know, wanting to do a drive or a campaign around collecting different kinds of materials. And if you feel that there's an opportunity to start to see, ask the questions with your local collection points. You know, a lot of people will say, well, I'm collecting old clothes and old textiles, and therefore that's for recycling. I would probably say that as inquiring minds as we all are in the world of science, I think as we would always do, ask the next 10 questions and go, but what's going to happen to it? How is it going to get recycled? Where is it going to go? What kind of products are being made? Because quite often we get told at the first point of collection that, oh, drop off your clothes here or drop off this here, and we will recycle it. But I think what I would encourage you all to do is to be able to say, okay, what's the next step? What's going to happen? Are there ways in which we can remanufacture? And if indeed there are opportunities, we would be more than happy to start to imagine a collaboration where Smart Center can play a part. If there is an opportunity to do so, we would love to work and provide that kind of scientific collaborative opportunity to take microfactories out to the world. And that's exactly where we are sitting on that, embarking on that journey, where a lot of people from different parts of the world who are asking us about it. And again, we feel very overwhelmed, but also with that kind of show of support from various people across the world. But I think it comes right down to that fundamental question when all of us as individuals can ask those questions. Now, wait a minute, I'm not quite convinced that this is really recycling or remanufacturing. Just because you collect something doesn't mean that you're automatically recycling, right? So collection and aggregation of materials is just the first step. When you hear and you see signage somewhere where people say, well, drop off your old whatever clothes here and we're going to recycle it, where you need to ask what is really happening to it, you know, and what's really happening behind the scenes. And then they'll say, oh, well, I've got a service provider who takes it away. Okay, well, what do they do with it? And what do they do with it? And I think as we are all curious and inquisitive minds getting together, ask those important questions, because by asking those important questions, you will show to your retailers, you know, that, hey, you know, I want to know what's happening to the end of life products. I want to know what kind of programs you have on offer. So connect with retail, not just at the point of purchase, but at the reverse side of it. We go and buy things, but we also have to connect with those retailers. What kind of product stewardship responsibilities that they have put in place? So I think once we start to ask those questions, you will yourself start to see that there are some that are doing the responsible things, and yes, they might need more support, but I'd be absolutely open. I'd direct you first and foremost to our Smart Center's website. So that's smart.unsw.edu.au. Have a look at some of the cool videos and things that we have up there. It hopefully inspires people to think, you know what, there might be better solutions out there. How about I go and find out? And I think knowledge is the right point to start, and then the translation of that knowledge into practice, so that we can deliver on impact.
Veena, thank you so much, and for introducing us to this crusade that you are on to change the world. I think given the interest in the chat, you've probably got a few people who are going to join you on that. I know you've got to go, so can we please, all microphones on, give it up for Professor Veena Sahajwalla. Thank you so much for your time, and best of luck with everything to come.
Thank you.
Cheer a lot.
Thank you.